Welcome to another lecture. In this lecture, we'll be talking about classes. Really what we're going to be referring to here is object-oriented programming, if you've ever heard of that. All it really refers to is that everything is looked at as being like an object. You can kind of think of it as like a person, place, thing kind of thing. Like a noun. Whenever you're writing a program, anything that could be a noun, a person, place, or thing, you could make into a class. Now, it is possible to write Python programs without using classes. We've done that all semester without defining classes. Now, actually, you have been using classes, but you just haven't noticed. We really haven't really come out and just explain that that's really what you're using. Strings, for example, that's a class. So are ints, so are floats, but we haven't treated those really that way. We've just treated them as data types. As you get more familiar with classes, you'll start seeing that just about everything in Python really is a class, is an object. If I'm throwing together a really quick program, quite often I won't even mess with defining classes. But if my program starts becoming more complicated, quite often I will start defining some classes. And when you want to define classes is, for example, whenever your program does start getting bigger and start getting more complicated, but it's whenever you start seeing that you can start breaking your problem down into several smaller pieces. And object-oriented programming allows us to do that. It allows us to be able to take a bigger problem and break it down into smaller pieces. So the best way to get at this is probably just look at a couple examples. The basic class definition. You start off with the keyword class and then whatever your class name is. That could be just about anything. You can think of it as kind of like a variable. So it could be just about anything that, if you could create a variable with that name, uses the same rules and syntax as creating a variable name. And then it's optional, but the vast majority of the time I see it being defined is the init, or the initialization function, which you start off with def, like what we did with functions, and then you have two underscores, then init underscore. Whenever you see the underscores at the beginning and the end, those are special functions that perform special tasks. And we always start a function in a class definition with the word self, which refers to its own object, its own self, and then any arguments that are necessary. Now, you don't have to have any arguments, but quite often they are necessary. And then you have your body, which is just your body of your function. So a class is the functions of a class are a lot like functions we've seen before. The only difference is that we started off with in the argument list with the word self. So down here, here's another function, and it's exactly like how you define other functions, except for the self as we see here. You can have as many functions as you like. In the init function is where we set and initialize values, kind of like how you do at the beginning of your program. If you're wanting to set a variable equal to a certain value and then you'll modify it, let's say total, for example, you set it equal to 0 and then you're going to add 1 to it or add some value to it each time you execute the function. That's what you do in the init function. You're initializing things there. So let's look at a real life example, probably the best way to do this. Let's say we're writing a program in which we want to keep track of how many times a person walks around like a lap, or it could be running around a track. And every time they walk or run around the track, we want to keep track of the number of laps that they walk. And so we'll have our person class, and in our initialization function here, we want to give the person a name and an age. For some reason, let's say that those variables are important and we want to be able to keep track of those. And we want to be able to keep track of the person's name and the age and the number of laps that they run or walk. And so we'll set laps equal to 0. Also, one thing to notice here is that before every variable, we started off with self.name, which these will be variables that are defined and used within this function. So we'll start those off with self, so it knows that it's referring to just this classes or this instance values, variables. Then down here we have a walk function. And so every time that we call the walk function, we're going to increment the laps variable by 1. If we need a way to be able to get the number of laps that somebody has walked, and so we're going to write a function called getLaps. You could name it whatever you want. It just needs to be somewhat descriptive, and so I chose getLaps, and I will return self.laps, the value that is in this variable here. Then this last function here is actually the string function for the person class. And what it does is if we decide that we want to print out a person, it will execute this function and will print out whatever we set it in here to print out, which in this case it'll be name colon the person's first name, the person's name, and then the number of laps that they have ran. So let's actually use this class that we've defined. The way that we define the class, or the way that we use the class, is we set a variable equal to the name of the class, and then we've got to give values to the variables that's in the argument list of the initialization function. So this will create a person named Timmy with an age of 20. And then each time we call person.walk, we increment that lap variable by 1. And then here with the print function that we have where we're print my person, what print does is it will look at this, it knows to execute this string function here and output whatever's returned here. So if we copy and paste this code with the definition of a person class, we'll get the following information that'll be displayed. The next several sentences pretty much just go over what I've just explained. If you don't define the string function, and if you print out the myPerson variable, you get something similar to this, which is mostly just gibberish. And what this is really saying is that there is a person object at this memory location, and that's all that it prints out. Now that's not very useful for us humans. So quite often, if you're interested in printing out an object, you'll want to define that string class. It is not required, it's not mandatory for you to define a string class for all of your classes. You don't have to. But if you do find yourself wanting to be able to print out some error messages, stuff like that, or be able to print out some debugging information, quite often it's kind of nice to have this type of information, so that way it's easier to track certain things. Now, there's other things that you can do. There's other functions, special functions, besides just that string function. There's also one called like an equals that allows you to be able to compare two people together. And actually in your reading lesson in the book, it actually talks about some of these. So I'm not going to go in a huge, I'm not going to go in a lot of detail on those. But what they do is these types of functions allows you to be able to compare two different people, and then based on how that equals function is defined, one may be greater than the other. So let's look at, we've talked about Timmy, but let's talk about, let's have two different person objects. Here we're going to have one called John and another one called Sally. John is 30 years old and Sally's 25. So here we can call these one at a time, call Sally walk, John walk, and Sally walk, and then we can print out the status. Now notice that by doing this, by calling Sally walk, John walk, and Sally walk again, we're not having to worry about certain intimate details about that person object. For example, we don't really care so much about what their name is, their age, or exactly which lap they're on. Whenever we call the walk function, it takes care of what it needs to do to add one to the lap, stuff like that. So notice that we're able to hide some of these details, things that we don't have to worry about. So we're kind of black boxing this. That's one thing that object-oriented programming is really good at, is that whenever we define the function or define our object or person class, that's when we worry about those details of what the person class needs to be able to do. We create defined functions in that class, so that way that'll take care of whatever needs to happen in that class. And then later on, whenever we're trying to solve a bigger problem, like for example, right now our problem is keeping track of John and Sally. We just got to keep track of each time that they decide to walk another lap. And so that's what these 3 lines of code does. And whatever needs to happen in that walk function happens. We don't have to worry about that at this level. That's being taken care of at a different level. And then we can just print out their status. We can just print out Sally variable and print out John, the John variable. And these will print out the person's name, the number of laps they've done, so on. So we don't have to worry about all of those details. So what I suggest that you do is copy and paste the person class definition into Phony, then copy and paste some of this code here for John and Sally, execute it, play around with it a little bit, maybe define some of your own functions. Try to maybe define a run function. Maybe try to define some other functions there and call them and see what happens. Maybe modify the string function and see what happens there if you call it on a string function that you've defined. We could also let's look at another example. Here I'm defining a class named worker, and there's certain things about the worker that we're interested in. They've got some kind of an ID. That's some kind of identification number. It could be social security number. It could be some kind of employee ID. It really doesn't matter. Then we have their name, then an age, a wage, which that could be wage per hour. It could be, wage per month, year. It really doesn't matter at this time. Just while we're consistent, the number of dependents that worker has and the number of years that they've worked at the job. And so as we pass these values in, we set ID, self ID equal ID. Now, these variables here don't have to match up. You can have ID, you could have some other value here and set self ID equal to something else. Right now, I just, in a lot of cases, whenever I write code, I will use the same variable names because it just makes it easier, but you don't necessarily have to do that. Like up here for name, you could write full name up here instead of name, and then right here, write full name. So you'd have self.name equals full name. That's perfectly possible to do. Then for the string function, I'm wanting it just to output the name. That's all I'm really interested in. And actually, there's a typo here. I should have a %sign and then name. I will probably change that by the time you see these notes, but that's something I'll have to correct. And then down here for the add, what I'm going to do is there is a special function called add. So whenever you do like worker plus another worker, that will define how those two worker objects are supposed to work, how the add is defined between that relationship between those two workers. So we can do stuff. We can add other classes. We can add one class plus a number or a float. And we don't necessarily have to just add numbers together. We could define our own class. We can define arithmetic within that class. And what we've decided to do here, what I've decided to do, is just add the wage of this worker with the wage of another worker. Now, this add function, it could be defined as anything. It could be anything else. It could have been number of dependents. It could have been the person's wage. It could be the number of years that they've worked. It could be any of these variables that we have here. I just picked wage. It could have been any of the others. So let's create a worker called Jolin. And his ID number is 123. His name is Jolin. His age is 30. His wage is 15. And he's got 2 dependents. And the number of years that he's worked here is 5. And how do I get those values? I look up here and I see that the first argument here, and you ignore self. You don't look at it. But ID goes with the first value here. Name goes with this one. Age goes with the next one, which is 30, and so on. So for Becca, she's a worker. Her ID is 456. Her name is Becca. She's 32. She makes $16 an hour. She's got 3 dependents, and she's been here for 7 years. So I could write a print statement just like this and just say, total wages of Jolin and Becca are, and this is legal. I could just say Jolin plus Becca, and what Python will do is whenever it sees this, it goes, oh, they're referring to the add function of a worker. So it knows to go here, and it will take Jolin's wage and add it to Becca's wage, and we'll return that value. Now, isn't that neat? Now, this is a little bit of a silly example, but isn't that neat that you can define your own data types? You can create your own class, and then you can define the arithmetic that does that you want to perform. That is so slick. That is so neat to be able to do that. So down here, I say that we could actually do the number of dependents instead. So instead of defining the add function like what we have up here for the wage, we could have defined it like this or for any other variable. And so for a list of other variables that you may, a list of other functions that you may want to look at or define for your classes, you can click here on this special link and it takes you, guess where, to the Python documentation. And we're not going to talk about all of these. In some of your reading, it does talk about them, but I'm just going to quickly go over a few of these ones that I consider to be really, really important. Let me see. Here we have string, which we've talked about. REPR is a representation official string representation of an object, so you could define the REPR. Quite often, this will be used if the string cannot be found. Also, there's a bunch of comparison operators, less than, LT, LE for less than or equals, EQ for equals, not equals, greater than, and greater than and equals. So you could actually write a class, define these functions, and define how they relate to one another. You could use a person's wage. You could, like for in our worker class, you could use a person's wage. You could use the number of dependents, maybe the number of years they've been there. That would allow you, if you did use the number of years they were there, you could define seniority. And you could say, if Jolyn is greater than Becca, then do blah. And so this adds a lot of flexibility. It adds a lot of power that you could use with defining your objects. There's several of these. Hash comes in, sometimes a little bit important. It's something that we're not going to cover. You could do a Boolean if you wanted to. And why would you want to do that? Well, remember our conditionals. You could define a Boolean based on maybe if a certain user, let's say that there's some kind of tenure or something like that with the worker. You could actually have the worker define true or false based on some value, some variable, or some calculation that you do. And so you could define this function, and then it would return true or false. There's also other ones in here. There's a ton of them. There's a lot of them that can be defined. There's actually several for arithmetic that I don't see here, but you could do a Google search on underscore underscore ADD underscore underscore. Let's actually do that. Let's do that. Python. Let's see what comes up. Let's go into the documentation. Let's see where it takes us. So if you're going to write a lot of Python code, you definitely want to get used to the documentation. Now, as you go through it, there are a lot of things are going to be over your head to begin with, but if you take your time and just learn a little bit at a time over a period of months or a few years, you'll get better at it. I'm still learning things, and I've been using Python for like 20 years off and on. And so they're constantly adding things. They're kind of shifting things around. I'm not really seeing it. Over time, you just start picking up some of this stuff. Is it under operator? Yeah, I bet you it is. So there's a not function. Is not, absolute value. You could define an absolute value of a class. Let's see what some of the others. Multiplication, here's multiply. So you multiply two numbers together. Find the negative of something. So if you want to treat a class as like a number, you can do a lot of neat things with it. So yeah, take the time to look through some of this. Here's subtraction, SUB. For most of the math ones, they're three letters, SUB, MUL, DIV for divide. And so it's really slick. It's a lot of neat things you can do if you want. You don't necessarily have to. You don't have to define an add function, for a class, but it's there if you want it. If you want that type of flexibility, it's there. So let's go a little bit further. Let's go the extra mile. There is a built-in function called isInstance. Since we've talked about classes, we can now talk about this. We can see if an instance is of a certain type. If it is, then we can perform some type of some kind of work based on that. For example, in our add function, let's say that we want to be able to add workers together, but we also want to add integers or floats to a worker. Now you may say, well, why would I want to do that? Well, there could be instances in which you want to do that. Depends on what you're trying to solve. So what we can do here is we can check to see if the instance of the other variable is an integer or if it's an instance of a float. If it is, then we just want to take the number of dependents and add other, because we're going to have number of dependents plus some integer or float here. Else, if the instance is another worker, we would use the regular definition that we had before, which is number of dependents plus the number of the other person's dependents. Now, in the first case, I showed you wages, but here I'm using number of dependents, which is okay. And else, let's say that we don't have anything else. We're not really sure how to do this. And so for right now, what we're going to do, and this is actually a bad thing to do, is we're just going to pass. Really what we should do here is raise some kind of an error and produce some kind of error to say, whoa, wait a minute, I don't know how to proceed. I don't know how to go on about this. But the whole purpose of this is I want you to know that this does exist. The isInstance function does exist, and this is kind of how you would use it. So for a little exercise, take and paste this into the definition of your worker class. And then up here where we were adding Jolyn and Becca together, right here, see if that still works. But then take this print statement and say Jolyn plus some number like 3 or 3.2 and see what happens. That should take whatever's in Jolyn's num dependence and add 3 to it or whatever. So if it was 2 dependents plus 3, it should come up with 5. Maybe create a print statement that says the number of dependents of Jolyn plus 3 is Jolyn plus 3 out here, and see what it does. So you should be able to get this to work for Becca, for Jolyn plus Becca, and then Jolyn plus, and then some real number like 3 or 4 or 5. And so that allows you to be able to make your like addition, subtraction operators a little more flexible. So that way they just don't have to deal with one data type or one kind of class. They can work with other classes as well. Getting down here, there's some extra exercises. Feel free to go through some of those. You should be able to do most of these. And let me know if you have any questions.